Hello, my name's Dick Vane-Wright, and it's my honour and privilege to give the opening paper of this conference. The title of my talk is Diversity and Geography of the Apollos and Their Allies, a brief introduction. Now, the butterflies, superfamily Papilionoidea, form a monophyletic group within the Lepidoptera, a major insect order currently estimated to have evolved about 300 million years ago. They're the sister group to the caddisflies. The oldest Lepidoptera extant are probably the mandibulate Micropterygoidea. Here's one of these beautiful little things. Unlike the vast majority of Lepidoptera, they have chewing mouth parts and are thus considered to be very primitive. The butterflies emerged about 200 million years later and appear to be the sister group of all other Obtectomera, the major terminal clade that includes the Galechioids, the Pyraloids, Noctuoids, Geometroids, and the Bombicoidea. Butterflies are thus a group of day-flying moths that, on present evidence, originated in the mid-Cretaceous some 100 million years ago. It might be significant that ants first appear in the fossil record at about this time, but that's another story. The Papilionoidea comprise 7 conventionally recognized families. The swallowtails, birdwings, Parnassians, and their allies, the Papilionidae, form a clade of about 600 species, now regarded as the sister group to all the other butterflies combined, the other 6 families. So they have the Papilionidae have this relationship to the other 6. Now, the 6 are non-coordinate families. If made coordinate with respect to the Papilionidae, these 6 would be united as the Hesperiidae sensulato. Hesperiidae as a name simply because it's the oldest one, our oldest named taxon out of those families. Now, taken as a whole, the Papilionidae, all 600 or so of them, show a classic latitudinal species richness profile. At the equator, going all the way around the Earth, there's something like 250 species of swallowtails. But if you go far to the north, Moscow, or to the south, Sydney, those sort of latitudes, by the time you get that far north or south, there's literally a tenth or less of the number of species. At the latitude of Moscow, about 19. At the latitude of Sydney, about 26, going all the way around the Earth. Now, the Papilionidae have long been divided into 3 subfamilies, with Boronia sister to the other 2, and molecular work corroborates this. So the Boroniinae have this relationship to the Parnassiinae and Papilionae. The extant Boroniinae comprise a single Mexican endemic, Boronia brevicornis. So it's distributed in Mexico. This is a nice map from a very recent paper. Now, at 100 million years ago, when the butterflies are thought to have evolved, the Earth looked something like this. This is a map taken from a book called Frontiers of Biogeography, which has conveniently very nice representations of how the Earth is thought to have changed over the many millions of years. At this stage, you see that India is still far to the south, as indeed are Australia and New Guinea. They're not in their modern relationships. And North America and South America are still relatively far apart. Now, if we plot the existing distribution, known distribution of Boronia on this map, you find that's where it is. Now, Boronia itself is a very interesting butterfly, not least the polymorphism in the adults, which seem to involve mimicry. Now, switching to the Parnassiinae, they consist of about 60 to 80 species divided among 8 extant currently recognized genera. They occur in the northern hemisphere only, above latitude 15 degrees north. Now, this map, wonderful map from a paper by Fabian Condamine and colleagues in 2018, shows a row of thumbnails for the 8 genera across the top. And we see that all of them, with the exception of Parnassus, are really rather small genera with 1 to 5 species recognized. Now, if I put in the 40 degrees north line, you see that all of them can be found at that level, with one exception, and that's Butanitis, which occurs from about 17 north to 38 north, and is the most southerly of all the Parnassiines. But it's still well to the north of the equator. Now, if we look at the small genera, they can be divided geographically into a western group and an eastern group. This is the western group: Xerinthia, Archon, Alencastria, Hypermnestra, and they occur collectively from Spain east to Afghanistan. If we now look at the eastern group, there are 3 of them: Sericinus, Butanitis, the southern one, and Ludorfia. They occur collectively from Bhutan east to Japan. Now, the only large genus in the group, Parnassus itself, occurs across almost the whole of the Old World temperate region, doesn't occur in the British Isles. In addition, 5 species occur in Western North America. And this is one of them, Parnassus eversmani. And in this context, it is a very interesting species because it occurs, you can find it in Russia, for example. You can also find it in the Yukon in North America. Now, in a recent paper, it's claimed that the Parnassiini originated in the late Eocene in Central Asia. Well, again, same source of maps as I used before from Frontiers of Biogeography. And this is a map of the Earth now, not at 100 million years, but at 40 million years before present. You can see that North and South America still haven't joined, but India has now moved right up to its more or less modern position, but Australia and New Guinea are still a long way from their current location, right up against Southeast Asian Malay archipelago. Now here, if we put not the current distribution, but the idea of the origin of the Parnassiini, we see they sit there. Now, the Parnassiini are an outstanding example of a north temperate distribution pattern, about which Terry Irwin stated, with respect to ground beetles, at the taxon level of tribe, very few groups have a north temperate distribution without having a sister taxon in the southern hemisphere. Now, family group taxa that have no representatives in the tropics but occur at higher latitudes in both northern and southern hemispheres are said to exhibit an amphitropical distribution. Such distributions are of great interest for biogeographers. However, the reality or meaning of a given example is entirely dependent on the taxon in question being a natural or monophyletic group, as the following illustrates. This is a map supposed to be an example of an amphitropical distribution. It's actually a family, or was thought to be a family, of freshwater fishes, the Perichthidae. And this map is taken from Humphreys and Parenti, 1986, the classic tome on cladistic biogeography. However, our notion of these species, or these fish, their classification has moved on since then, and the Perichthidae are entirely southern, and the northern distributions indicated on this map are not, those taxa do not form the sister group to the true Perichthidae. So This is in fact not an example, not a reliable example of an amphitropical distribution. And that, of course, applies to all these sort of speculations in biogeography. It's only as good, really, as the basic taxonomy is sound in terms of reflecting natural groups. Now, there are a number of questions that arise from what I've told you about Boronia and the Panaceini. Excuse me. How should we interpret the North American Mexican distribution of Boronia, which represents, according to some people, the oldest lineage of all extant butterflies? This I have to question. The oldest butterfly lineages are surely the Papilionidae as a whole and their sister group, all other butterflies, the Hesperiidae sensulato. And if you doubt the logic of this, I refer you to a paper by Frank Thorsten Krell and Peter Cranston that appeared in 2004. A key little paper on these interpretations. Thus, we have to question if Boronia is simply all that is left of a formerly far more diverse and widespread clade. Boronia is monophagous on a species of Vachelia, which is a mimosoid plant. But is Boronia nevertheless evidence that the ancestral butterflies evolved in North America and fed on Fabaceae? I'm not sure it is. This is a very recent cladogram showing all of the major groups of flowering plants, published in Nature in April. And if we put in the 100 million year line, we see that all of the major flowering plant families were available to the ancestral butterfly to feed on whatever they were already feeding on, as it were. All the major families were in existence. Now, Boronia feeds on a member of the Fabales, which is a quite advanced group family of plants. But again, it was already in existence, so it's perfectly plausible. Interestingly, though, in some other Papilionidae, including species of Graphium, they feed on Magnoliales, which are among the oldest lineages of the flowering plants. But again, they all existed when butterflies are thought to have come into existence as a separate group. Now, this is a distribution of Vachelia, the only plant on which Boronia feeds. It's widespread. It's formerly included in Acacia and has been estimated to have originated only about 25 million years ago. The subfamily Mimosoidea is thought to have originated about 55 million years ago. Now, if all these figures are correct, if we imagine Boronia to be a lineage that is up to 100 million years old, then it must have been feeding on something else than Vachelia when it first started out, so to speak. More questions. How good is the evidence that the Parnassiini form a monophyletic group? Has been disputed. But even if they do, what is to be made of their north temperate distribution pattern? A pattern which, although uncommon at conventional family group rank, is common at generic rank. Suppose all Parnassiine genera had become extinct except Zorinthia. Would we still conclude that the group evolved in Central Asia? There are two fossils that are referred to the Parnassiini, and those are both European, Thetis from France and Doritates from Italy. Final set of questions. Did butterflies co-evolve with plants? At the growth level, it looks more like butterflies radiated onto the flowering plants than co-evolved with them in any strict sense. Since the classic paper on co-evolution of butterflies and plants by Ehrlich and Raven, this is a view often expressed. There's nothing new there. Another sort of generalization from the biographer Leon Croisat is that Earth and life evolved together. Well, I think that's undoubtedly true, but with respect to analysing deep geographic patterns, how do we allow for extinctions, most of which leave no trace? And that could well be the case with the history of the Baroniini. We have no idea, I don't think. Anyway, I'm going to end there with those questions and this wonderful picture from the wonderful Butterflies of India website showing 4 Butonitis lididale, and with the following thought that in closing, we have to recognise that the job of Swallowtail Butterfly and Birdwing Trust is to try to prevent extinctions of these wonderful insects, so at risk due to our human enterprise. May SBBT succeed and succeed well. Thank you all very much.